All right, so when A is not 1, right, we have to look at that. Your rules are going to be the same, your order, right? You have to make sure all your terms are on one side, which it is, okay? But before you put in your spaces, if you don't have a 1 here, you have to factor it out. And what you're going to do is factor it out of only the first 2 terms. So to factor out, you divide. 4 divided by 4 is 1, so 1x squared. 20 divided by 4 is 5, so 5x. Okay? You're not going to take it out of the C term, and the reason is because the A and B term, this is what turns into the binomial squared for vertex form. That's why, just like the negative we did last lesson, you only do the first 2 terms. Then, to fill in those spaces, my formula, right, b divided by 2 squared, b is now 5. It's not 20 anymore, it's 5. So I take 5 divided by 2 squared, which is 25 fourths. Okay, we're going to have a fraction. So if I add 25 fourths here, what am I going to subtract out here?
25 fourths.
No. Because whatever I'm adding in, since it's in the parentheses, it's getting multiplied by the 4. So I'm not really adding in 25 fourths, I'm adding in 25 because the 4's will cancel out. If I multiply 25 fourths times 4, the 4's cancel out and I just get plus 25. So by putting this here inside the parentheses, I'm really adding a 25, so I subtracted 25. All right, so then, right, this is the hard part, but not really, because to factor this, what do I multiply equals 25 fourths, but add equals 5? Yikes. But what you should notice, and if you look back in your homework, there's a trick. Whatever b over 2 is before I square it is always the number that goes into my binomial. Did you guys notice that when you're doing your homework? Whatever b over 2 is before I square it, right, it's got to be before, that number always goes here. And that is going to be a huge help when I have fractions, because to factor that is nearly impossible, right? So that's always the same. So I would write that in your notes somewhere so you know that's always the same number. And then you can combine like terms, so minus 24. And then there I can stop and write my vertex. My vertex is going to be negative 5 halves, because that means left 5 halves, down 24. So that's the first part. The second part is now solve for your roots. So here's my function. Set it equal to 0, right? So what am I going to do? I'm going to add 24 both sides, divide by 4, because I got to get the parentheses by itself. So I can square root, so divide by 4. So I get x plus 5 halves equals 6, right? So I'm getting there, right? I'm getting to the x slowly but surely. I had to move a couple of things. Still got to move one more thing, the square root, so that's gone. So x plus 5 halves equals, and remember, always plus or minus. Plus or minus square root of 6. And then subtract the 5 halves over. So my final answer would be x equals negative 5 halves plus or minus square root 6. And there's my roots.
Big bada boom pow.
Okay. So again, step 1, make sure all your terms are on one side. So 3x squared plus 6x minus 1. Right? All my terms are on one side. A is not 1, so A is 3. That means I have to factor a 3 out of the first 2 terms. So I'm going to have a 3 out here. 3 divided by 3 is 1. 6 divided by 3 is 2. Then I'm going to have some spaces, right? It stays the same. Space and space. B over 2 squared which is going to be 2 divided by 2 squared, which is 1 squared, which is 1. So I add a 1 here, but what am I going to do out here? Subtract what? 3, because I'm really adding a 3 because of this 3 here. This 1 is getting multiplied by 3 because it's in the parentheses. So I'm really adding a 3, so I would subtract a 3. You got to be careful. If you're putting a number inside the parentheses, you have to think, what is it getting multiplied? That's what I'm really adding in. Okay. Then I can factor 3x plus 1 squared minus 4, right? This number before I square it always goes here. Negative 1 minus 3 is negative 4. And then I know my vertex. My vertex is negative 1, negative 4. Okay. Now go to solve. Right? What are my roots? Okay. So 3x plus 1 squared minus 4. Okay, so solve for x. Add 4, divide by 3. You always want to get the parentheses by itself. So add 4. Then divide by 3. So x plus 1 squared equals 4/3. Okay. Square root. That cancels that out, and I get x plus 1 equals plus or minus 2 root 3 over 3. Right? Easy. Subtract the 1. Subtract the 1, right? And I get negative 3 plus or minus 2 root 3 over 3. And that's my final answer. All right, so you guys are probably thinking timeout, right? Time out, Miss Chapman. Where in the world, right? Where in the world did this get into that? Right? What happened?
Oh, yeah. You have to do 4 divided by.
Okay. So we need to review this from Algebra 1, right? You don't remember it, and that's fine. So let's go over it. Let me kind of reteach it real quick, okay? When you are square rooting a fraction, your rule with square rooting a fraction is you can break this up. You can say this is the square root of 4 over the square root of 3, okay? And then you simplify. I can say the square root of 4 is 2 over square root of 3. Okay? But the rule in mathematics says you cannot have radicals in the denominator. It looks messy is why. Okay? It's a good answer. It's the right answer, but we have a problem with this because it's hard to visualize what 2 divided by square root of 3 means. Okay? So we rationalize the denominator. And what that means is whatever square root you have on the bottom, you're going to take the top and bottom times that square root. Right? Whatever square root you have in the bottom, doesn't matter, square root of 2, square root of 3, square root of 5, you take the top and bottom times that. Because I know the identity property says if I take any number times 1, which this is a 1, square root of 3 divided by square root of 3 is 1. It's a fancy 1. If I take any number times 1, I get the same number. Okay? But I'm just doing this because then if I multiply the tops, I get 2 square root of 3, 2 times square root of 3, can't combine those. Square root of 3 times square root of 3 is the square root of 9, but what's the square root of 9?
3.
3. Okay? So if you plug these two numbers in a calculator, it's going to be the same decimal, but this just looks nicer because it doesn't have the radical in the bottom. Okay, let's try another one. So how about square root of 5/6? Okay, so square root of 5/6, it's a fraction, so break it up. Square root of 5 over square root of 6. Right, they don't break down, right? 5 is 5, 6 is 3 and 2. Okay, so I say, what's the problem? Square root of 6. So you take the top and bottom times the square root of 6. Square root of 30, because 5 times 6 is 30. Over 6, because square root of 6 times square root of 6 is square root of 36, which is 6. And then that's done.
Oh, so you just multiply the top
just multiply the top and bottom by whatever radical's there. Let's try another one.
What do you mean radical? What's the radical?
The square root. The square root. Let's try, let's try 3/8. 3/8. So I'm going to say square root of 3 over square root of 8, but do one of those
8 works.
8 simplifies.
So you have to do 2 and 4.
And
then 2 and 2
Good.
4.
So I can take
so
a
then
2
2
out.
goes outside of it.
Yep, I can take a 2 out. This 2 stays.
Yeah.
But what's wrong with that answer?
You have to multiply the 8.
The square root of 2. This 2's fine, but this square root of 2 is the problem. So I take the top and bottom times square root of 2. So I get good, square root of 6.
Over square 2.
Over 4. How 4? Because I have a 2 times the square root of 4, which is 2. Right? This is really 2 times the square root of 4. If I combine those, which is 2 times 2, which is 4. Okay. Try one more. Making sense though? How about the square root of 4/5? So this would be square root of 4 over square root of 5, which would be 2 over root 5. Very good. 5 is the problem, so multiply by square root of 5. So I get 2 square root of 5 over square root of 25, which is 5. Good. Okay, so all terms are on one side, right? I need to get rid of this 9, right? You can't have the 9 there. So factor out a 9. 9 divided by 9 is 1. 12 divided by 9 is 12 ninths. Right? The b term is not always divisible by the a term. And then simplify that though, make it easier. So let's say 4/3 instead of 12 ninths, right? Okay. Now, when we have a fraction as a b term, and I have to figure out what I'm putting in those spaces, my rule is b divided by 2 squared, which would be negative 4/3 divided by 2 squared, which is very messy. So what you need to remember is dividing by 2 and multiplying by 1/2 is the same thing. So whenever you have a fraction, instead of dividing by 2, let's multiply by 1/2. And that'll make it easier. So this would be negative 4/6, right? Multiply tops, multiply bottoms, which would be negative 2/3. And then finally I can square it 4 ninths.
Can we just do it on calculator?
So I'm going to add 4 ninths here. Whoops, not 9/4, 4 ninths. So if I put a plus 4 ninths here, what am I going to subtract out here?
9.
4, because 4 ninths times 9, the 9's cancel out, and I get plus 4. If I take 9 times 4 ninths, that's 4. I'm really adding 4. So I subtract 4. So then I can factor, which thank goodness, because now I know b over 2 before I square it is the number that goes in by binomial. So less thinking on that part. 9x minus 2/3 squared minus 6. And then I can stop there and say what my vertex is. My vertex is going to be 2/3 negative 6. And then I still need to keep going. I need to solve. So we'll take that 9 and solve it. All right, let's finish this. Add 6, right? Add 6.
Yeah, add 6.
And then what? Divide by 9?
Yeah,
Let me get some
so
more
it's 6
room
over
here.
9, which actually equals 2 over 3.
Yep. Very good. Reduce it down.
And then I don't know what to do.
And then we're looking at a square rooting a fraction again, right? I'm going to square root both sides, and then we have to remember, okay, how do I square root 2/3? Okay, so square root of 2/3 is a square. Yep.
So it's actually 4, the square root of 4, square root of 6?
No. Square root of 2/3. What's the problem with square root of 2 over square root of 3?
They don't go.
The square root of 3. So I'm going to multiply the top and bottom times square root of 3. So then I get square root of 6 over 3. Because square root of 2 times square root of 3 is square root of 6. Square root of 3 times square root of 3 is square root of 9, which is 3.
Wait, why was 3 the problem?
All right, let's finish it. Plus or minus, right? Add the 2/3, so I get 2 plus or minus square root of 6 all over 3. And there's my 2 roots.